de notre petit déjeuner avec séance de données et R. R, c'est une language très populaire et très puissante pour data table. And we are continuing our tutorials or lunch learn dedicated to building packages. So as usual, I will start by sharing my screen, and we will just refresh what we have done so far. Because the idea is the following, that many of us develop good codes, and we want those codes to be used by other people, organizations, our colleagues, right? So I hope you can see my screen right now. So it shows the GC code folder where we are building the packages. So, and also I will provide a few links which we are normally using for this Lunch and Learn. So first, it's our GCcollab page. So if you are not there, please go and register. The other one is public page. It's on GitHub, hosted at OpenCanada, GitHub.io. And now this page is public. So some announcements will be posted there. And here we have also links to all the resources. By the way, one of them is a slider. We have access to slide, and you can post your question there or suggest a topic for discussion. And actually, I will open it as well. So when you have time, please go there and again, suggest a topic for discussion for Lunch Learn. Now, what else do we have here? Also, we have OpenCanada. Let's have a look. OpenCanada. This is a joint project with the Treasury Board Canada. So they have established this GitHub portal and essentially allowed us to use it to promote data, open data, and open data science. And in here, that's where we host this OpenCanada use our portal, but also you will see we have a collection of some applications already written. And for example, there is one which analyzes COVID, another one which analyzes PSAS, Public Service Employee results. So, and I will open this one. So essentially what we started doing, we decided to learn how to build our own packages when we already have some functions already written. So, and there was a lot of interest in building a library, for example, for visualizing and analyzing PSAS results. And indeed, it's a very powerful visualization tool to see how your department or your division is doing. So while it is loading, I will go back to R4GC portal, which we have built. Now in here, for those who are new, please go there. It's you should be able to access this directory if you are a Government of Canada employee. And here you would see a folder called codes, and there where we have actual source codes for a bunch of things, like for COVID, for example. And on our session 1, which was 5 weeks ago, we've just taken this R file, and this R file essentially it does just 3 things. It opens a file from University of Ottawa, or sorry, University of Toronto. And by the way, it also shows how to do it using data table. So I'm showing here how you can use data table, so we can practice data table skills at the same time. And then it extracts the most infected cities in Canada. But most importantly, it is using functions which are generic functions. And this is where we started this discussion, because always there will be functions which are generic, which we would like to use all over the place. So this is how we decided that we will be building not one package, but we will be building two packages. So one with generic functions, like for example, this one, we're using it as example. Function which just replaces efficiently in place in memory in a particular column, it replaces A with B. Like for example, it's a very typical function, in fact, where you need to replace name of a variable, New Brunswick, with the NB, for example. So very, very common. And this is done very, very efficiently using data table. So now I'm going back to our codes in R4GC and even folder up. And we started building GC packages. So in GC packages, we now have two packages. So one with generic functions, which can be used anywhere. And this is already built using the structure. And we have discussed in our first session that the way we will be doing it, we will be putting all our codes, whatever we want, right here in this folder called My Codes. And also, by the way, we'll be keeping our questions and answers in this file, packages 101. So this is where, in fact, I will be documenting all the insights we're getting from our expert, who I will introduce shortly. So let's quickly look into what is in this package right now. So the R functions are located in R directory. And let's open this file. By the way, now it compiles nicely. You can clone it, you can download it, you can unzip it, and it will run. So essentially, what you would see, it has now not only one function, which we written on our first session. And our first session, we just have written this function, which I have shown in the beginning, which is this replace. And we have shown how you can create a package which contains this function, and a few examples, how to use this function and how to document this function. But now we have added a bunch of other functions. And on our session number 2, we have talked about how to group all those functions in one documentation file. So we are using this, what is called rCgen package, which creates a skeleton. And if you want your functions to be documented in one help page, you need to use this line, rd name, and iv base would be the name of the documentation file, which is created. So now let's look into other files which are in the same directory. So you would see that documentation is created in directory man, and we have now a couple of files which are created there. And also we have other two files, which in fact we'll start discussion with those files. One is called description, and description is created automatically. And we're using commands which we will tell you about. And it has this portion which tells which libraries need to be imported, right? So it's very important, because then we have another file called namespace. And namespace also has import. This is very interesting. So this file namespace is created when you run your rCgen script, and this is where I will show now my RStudio. So RStudio, you see right now exactly the same file, but now it's in my RStudio. And you would see, in order to create documentation, you run this line, DevTools document. Now, what you would see that there are these 4 lines, import. And when you have them, it includes it includes these import lines in here. So that's probably enough to start. And we will switch now. We will talk about a few questions which I have in mind. But just to finish, in this GC package, we also have a package called rCanada. And again, it's functional. You can clone it. And what this function does, or what this package does, it will currently it has codes only to work with COVID data, but eventually we'll add data to process ATIP and PSS and everything. And COVID, now what you would see, and this is very important improvement since last time. Now in the past, I would need to have this source file, and I would need to source these utility functions, which I would need to copy from this IVIM package. Now, once IVIM package is already compiled, why not to use it? And it is located in a directory. I will show you. You probably know. So where you install your R, you have a directory win library, and you would see that the packages which I have created, rCanada and IVIM, they're already there. And in fact, if any of you would like just to use them, you can just zip this directory and put it in your Win library folder and just use it the same way as I'm doing it now. So that's beautiful. So because now I just need to call library IVIM, and that's it. And now I can use all those functions which are written inside IVIM. Okay, so that provides overview of where we are right now. And let me, by the way, we have also MS Team here. And let me just check quickly. Yeah, so this is how I'm. Yeah, so you would see that I have this package running right here. And the problems which I was experiencing is that you do need to be very mindful on that you include those import files or import packages here somehow. Okay, now let me introduce again our colleague from CFIA, Joseph Stinciano. So he has developed packages himself, and some of his packages are in CRAN. And he has done some training in building packages, but it's I find the way he's teaching is actually very efficient. It's probably more efficient than what Hadley Wickham has written in his big package books. So Joseph, I'll give mic to you, and maybe do you have idea how you would like to proceed? Do you want to share your screen, or do you want to use my screen?
I might share my screen at some point, but first I think we can go over your questions and concerns around the namespace file. So the namespace file in the package, part of its role is making sure that the functions that you create are actually exported to the environment so you can use them, and also that any package dependencies are imported in there. So if you can click on the namespace file.
Yes.
So this namespace file, the best approach for this file is to have it automatically generated. Now at the top it says this one was generated by our Oxygen. And the way that I update it is using a DevTools command. So it's that DevTools document command.
Yeah, that's the one which I'm showing on the screen right now.
Yeah. So when you run that, it'll automatically take any functions that you have that at export. So you can see on line 18 here at export, that's needed to indicate that that function is something that the user will be able to use. And because it's got that at export tag, the document function will add it to the namespace to make sure that it actually comes out. If you don't do this, you'll end up with functions that can't be used.
Yeah, now I'll give you an example. So you see, I've just renamed this function from 12 to 13, you know, so that we can play it live. And I will remove this import. So now I will run dev tools document and see what happens. So it's updating IVIM documentation. It's changing file namespace. It's changing EV base because I said that I would like to keep documentation in file EV base. Now, by the way, what is good here, you can put a question mark and the name of a function. And let's say there is a function like that, and it will show you, should show, yeah, so it is showing you, you see the way it is done, it shows you all descriptions of all functions which are which documentation for which is compiled using this rd_name tag. So, and for example, it's very convenient. So for example, these are a bunch of generic utility functions, you know, simple ones like without or not in, options, and now we have a new function here. So that's quite nice. Now you would see also we're using this table of content window. It's very useful. So because I have functions, some are just base, I call them base, some are specifically for convenience functions to work with the data table, with data table object. And these are created in a different file called ev.dt. So, and if I would run now the same help for dt.replace, replace. Yeah. So it will show you documentation. You see, that's how it looks. So it tells you the name of the file, where documentation is, and then it shows you a bunch of functions which are documented in the same description file. Also very useful. And by the way, you see the functions which I have now there. These are very simple but very useful functions, like keep columns, remove columns in place, in memory. It's like by pointer. It's very useful. So instead of copying big files, like when you have many columns. So that seems very nice. Now let's open namespace, and that's what I wanted to show. You see, the import files have disappeared, and it will not run because my file, this replace, so I have example here, and we can run this example. It's good to have examples, and we'll talk about examples by the way, because we need to learn also how to provide examples. So, and in fact, the second half of our tutorial today will be about how to write your examples, how to write your tests. So let's run this example here. So I created a table. I can view it, and then I say replace. Let me see if actually it works. Yeah, so see, it does not work. And I had this problem, and now I know why. Because you do need to include those files which we have removed. Yeah, so these files. Specifically, it uses data table. And now if I include this, by the way, I don't, for example, I do not use yet. I don't use yet. So we'll talk about this, because that specific function uses only one package, data table. Some other functions are using maybe lubridate or magread. So I had this problem in my head, like how do I need to import those things? Where do I need to import them? Because originally these 4 lines, Joy, you may remember, you put them here. So they were here. And then it's like I thought maybe it's not the way it should be. Maybe I should put them on top of my file.
Yeah, so I think there are certain conventions that can help avoid errors, and I think this is one of them, where any packages that you're planning on importing, if you have multiple functions in a file like this, you want everything at the top, like your imports, your variable name descriptions, and then the only things that should be paired with the functions should be things like the RD name, the export, the return, and examples. But otherwise, there's some main components there that should be at the top to avoid issues.
Okay. So what I will do, by the way, quick question. So if I do this, it will not treat them as a RoxyGen, right? It will be just as a regular. So I'll do a test. I'll do a test right now. So because what I want to do here, I just want to import data table. And now I run again DevTools document and see what happens. Oh no, actually it does. So it does add all of them.
Yeah, I think it's because the rOxygen is looking for that hashtag apostrophe. So as long as that's in there, it will add it to the namespace.
Okay, so you see, so now it included only one data table. So I have removed other packages because again, you don't want to maybe to include packages which you are not using. So now with this inclusion, now my this function should work. Let me. Oh, because now I need to recompile it. That's very important. So, and we talked about that. So we go to build, and actually, Joe, you said that we don't need to load all. So I'm even not sure what load all actually is doing. Why do we ever need it?
I haven't ever used that before. I normally just do like a clean and rebuild, and then when I want to check the package, I'll check it. So I'm not entirely sure what the load all is doing here.
Okay, and I made a comment about that. So in my cheat sheet. So I told you that I have created this package 101 RMD, and now actually it's becoming much better organized. In the beginning, it was just a collection of questions and answers. Now I do have specific sections there. And and we can fill information for each of those sections, like setup, overall workflow, license, description, RoxyGen for documentation, namespace, examples, and tests. Then and we'll talk about that, like what do we do with tests, then vignettes and test that. So you see, I'm doing it at the same time. Now let's try it again. We have rebuilt. Now let's try to. It has opened it, and by the way, what I do here, see, I'm checking my IVIM package has been updated 1235, so I know it's a new one. I can use it now even from my rCanada. It's very nice. So I found this is the best way, because actually I'm building my rCanada package, and every time I change something in utilities, I'll just make sure I have updated it in my Win library, and then I can use it anywhere else. So that's quite nice. Now let's try to do this thing again here. Okay. It's not running yet, but we'll leave that for now. I don't know why. Now One question which I wanted to ask you, because remember in file description, we do include imports. So these are not related to, because that's just description, really. This is not doing anything.
So what this will do at this level, at the description level, is when you add the packages to your imports, when someone goes to install it, if they don't have those packages, it will prompt them to ask them if they want to install those packages or update them. And then it'll abort the installation of the package if someone isn't willing to install those packages. So that's why you need the imports on the description.
Okay.
And that's separate from the imports on the namespace, because the imports on the namespace are specifically in regard to the functions and what they're using. So it's two separate things. The description makes sure you have everything you need for components of the package to run, and that namespace makes sure you have everything you need to actually run the functions. Okay.
So that makes good sense. Let me try to run this example with this file, with this function, with another example. By the way, also to illustrate the data table, I think, unless you wanted to add something, Joe, right?
The function may not have worked because you may have to recreate that dt object for your example, because when you cleaned and rebuild, it may have cleared the environment.
Yeah, actually, that's right. So let's run another example here, and we'll talk about it, like how do we package those examples? Where do we need to paste to put them? Because currently there, you see, I use if false, and actually they in the same file. Like I'm illustrating how to use them. So this is a good example. Everyone knows Iris dataset. So and what I do here is I will make. Oh, now I do. This is another good question here. So my libraries are actually not. That's a very good question here. So my libraries are not included by default, by the way. So when I run my IVIM package, it does not include those libraries.
So with like I was saying, with the description, the imports field will make sure that the necessary packages are installed, but the namespace and having the @import in the function file will make sure that the functions from that package can be called. So the problem that's happening here is that the mgritter package isn't in that import field, because remember you removed it earlier?
Yeah.
So you shouldn't ever need a function that runs all these library commands, because if you use the @import field in the function file, it'll make sure that package is available. And you can also import individual functions from a package. So if you want to avoid overlap, you could import a function of one name from a package so it's not masked by a different package.
Okay, that's very good. Now I'll get back to this, because I think that's not exactly true though, because I did try to, I included, so last night, I did include import. So it was right here. And still when I was loading it, it would not load lubridate automatically. So I would need to load it myself. So I'm doing it actually right now. So that's why actually I still created this function called ev packages, which I can to make sure that I can load all my packages which I need. It could be redundant. I'm not sure whether that's the correct way of doing it or not, but you see what I've done right now. So I have recompiled library. I have recompiled. Now, when I was running this file, let me try, because I have already loaded it, maybe. Yeah, because Yeah, so now it works, but I will need to clean because I have loaded already my grid. But you know, it's a little test which I will do later, because I do want to know this very important answer to my question. So, are those packages loaded automatically just based on these 4 lines, or do I need to explicitly open them?
So the recommended convention is to explicitly call the package with its given function using the double colon. So like mgritter double colon and the pipe operator. That would be the recommended way to call the function within a package or within a function file.
Yeah, you see, it's not easy though, because you do have this. It's very convenient. You cannot put the column, right?
Yeah, so you do need the imports field with mgritter, but you shouldn't have to call it in library to have it work within an R function file. You should just have to have it in the @imports field.
Okay, so I will test again, and I will let you know next week. So I'll do this little clean test, and we will know the answer by next Friday. Okay, so essentially, this is to illustrate. Let's just go back to this function and doing tests, because this is I'm showing here how you can do it traditionally, you know, like using filter and mutate. So in this case, what we're doing here, we loaded Irish dataset, and we want to replace Virginica with Virgin, just to make it shorter. So so we can do it now essentially. Okay, let me try it again. Just hold on. I need to. Yeah, we'll do it again. This is. Okay, I will need to investigate myself why it is not doing it, and it could be something again with the inclusion of those different packages. But perhaps now it's just a good time to switch to that question which I've started talking about, which is how do we provide examples for testing? For example, test. We talked last time, and you suggested that we could have all our functions, like all those examples, in separate files. And that's where you can actually test all of these, right?
So the tests, they need to be in a separate folder. It's called tests.
That's right. Yeah. But this would be kind of a final, you know, like final. So because in the beginning, when you're writing your function, you know, you play with them and you have good examples, and now you can put them, some of them, into test utils.
Yeah. So what I would recommend doing is when you're going to write an example for a function, like once you're comfortable with what the function does, I would write the test and then use the setup in the test as your example. Because to test any sort of function, you need to set up like your data table or your data frame before you run the function that you want to test on it. So what I would do is start with the test and then extract the example from the test, because you know that that example works if it passes the tests.
Yeah. Yeah. Okay. So by the way, this is a good example. I'm not sure why it is not running the function right now. I will compile it again. Maybe I will clean and rebuild again, just to make sure why. Because that creates a good example to explore. Okay, why it is not doing it. So it has loaded. Yeah.
Mm-hmm.
Now, one more thing, I'm just looking at the time right now. One thing which I wanted to touch upon is just how do we, when two people or more than two people work together and we're using GCcollab to, to merge our results. So last time, for example, you have made changes to IVIM, and actually not here. Sorry, it's in GC code, in GC packages in IVIM. So what you've done, you've forked, and then when you made changes, you've uploaded them as a new branch, and then I merged them. And maybe we'll dedicate one lunch specifically just to talk about how we can merge. But my question here, just for today, maybe, is there a good way of seeing all the changes? Like I'd like to see all the changes in my file. So that's the file.
Yeah, so if you click on branches to start, on the left side menu.
Oh, yeah, branches here. That's right.
There's branches. So that will, if you notice under the use R dev branch, there's in the middle, it says 13 and 1. That gives you just a quick statistic, how far behind the master it is, and how far ahead it is. And then if you click on compare on the far, or I guess that might work. Let's see. Yeah, so with that should, if you go all the way up to the top first, there's some important information. So you can see source use our dev on the left of the main window, and then the target master. So if there's multiple branches and you need to compare the differences between them, you can select which two branches to compare. But then this is going to tell you the differences that have been made between the two branches.
Yeah, okay. Now, my question was more about even within the same branch, changes have been made constantly. And for example, what happened, yes, so some of changes which I made were overwritten when I merged with your file.
Mm-hmm.
And then I wanted to go back and to see, the previous versions.
So if you click on the repository again, and then you click on commits, it'll show you, it's on the left side menu.
Oh yeah, commits.
It'll show you all the commits that have been made. And so I think if you click on one, it'll show the changes that happened. And this is why it's very important to have a very good title for your individual commit, because otherwise it can be hard to interpret what some of these things mean.
Yeah. Okay. Yeah. So indeed, we can talk about next step when, let's say, people would like to add a function, because we're building this utility function, and let's say you have a utility function which you would like to be added. What we do there.
So I think one standard of practice would just be making sure that if you do fork a branch off of this package, you're developing just one function or one feature, because that will help minimize any interference with other features in the package, especially once there's multiple people working on it.
And in fact, actually, that's why originally I wanted to maybe to split this file into smaller files. It's like, as I've indicated, that we have in here, I have files which work with the data table, and some are base, and maybe some will be with plot. And by the way, I have many more functions, of course, and I have this, what I call utils master copy. That was original. I remember where we started. I have many ideas for what could be used, and it could be for eventually for linking, data linking, and for plotting, and for anything. And then I thought, okay, I will create separate R files. One will be called evdt, another evbase, another evplot, evlinking, and maybe that's the best way. So you, let's say, just work on one file and I work on another file.
Yeah, and one of the ways you might be able to keep these associated with the same documentation file is that rd name tag.
Yeah.
So I haven't tried this yet, but if you have functions in different files, you might be able to tag them with the same rd name tag. So
Yeah.
that way the help still appears in one place, but it aids with that multi-person development where someone can focus on that one function without interfering with everything.
That's right. That's right. Yeah, that's, in fact, this helped me tremendously. So right now I'm putting them in one documentation file. So okay, that's probably good for today. But before we leave, I'll just show you where I am in terms of documenting, because it seems like we could really build maybe a tutorial, maybe together with you, Joseph, we can essentially build a tutorial with it will be simpler than many of those tutorials which are currently available, which are very big and which unfortunately actually use techniques which were developed like 10 years ago. So I built this, I'm building, it's in process, it's present continuous. And also you would see in this directory in GC packages, if you have any of you have any questions related to, click there, and then you will get exactly to this file which I'm showing you right now on my screen, which is currently located in IVIM package, and it's R Markdown, and eventually we will be able to compile it and make a nice book or a vignette which describes. So it's located, I'll just show you. So that's in here, and you can, R Markdown is very nice tool. You can just knit it, and it defines the subject. So I think this is the structure of my current tutorial. Joseph, you can add something.
Yeah, I think this is a good idea. Maybe we could do something with Bookdown to make a simplified package tutorial. I think that would be great and super helpful, because Hadley Wickham's book, it's really useful once you know how to make R packages, but it's challenging if you've never made them before to read it and actually follow what needs to be done.
Yeah. So currently that's what I have right now, and it's gradually, with your help, it's getting a nice structure. So let's just recap the chapters or sections which I currently have there, and maybe in 2 weeks from now it will be complete. We'll have good examples. So resources from our GCcollab, that's where we discuss it. Then script which you have created yourself, and I added a few other lines there. By the way, also so really you need to use this library, and with this you can add data. So I started using data, by the way. In my rCanada, I have many data sets, and this is the way to do it. Very nice, very nice. So it all works, and again, it's all in GCcollab. So any of you are welcome to fork rCanada and see what it does. So now other things. Setup. We were talking about setup. So normally you have it elsewhere, and then you will move them. And then how you do it, different ways. How can you start from new project, from script, and we suggest from script. Now workflow, we'll talk about it. Like you copy files you need into our directory, and then you run documentation and compile them, and then we'll have already talked about our build ignore. We talked about license. We will provide. We talked about description. Now we have enough information about documentation and a little trick there on how to put it in one file. About namespace, I still have some questions there which I will explore. myself. For example, I was doing some reading, and it says that actually this is not the best way of doing it. There is a better way of essentially using it. So it's better just to do lubridate column dmy, for example. And what else do we have? And then what is left? Examples and tests using this test that package. And maybe we'll talk about that next time. So this test that package, how do we do it? And I will prepare a few examples, and maybe next time we will conclude with those examples. I will have a few vignettes, and maybe this will be enough. Do you have any other ideas or things to add?
No, I think that's a good plan.
Yeah. Now I experimented with RTools. They seem not to be required. You can live without them because I don't have rights to install RTools on my GC laptop. So it's okay. It seems like it's working. And actually, in the workflow in here, say exactly what we're doing. We're building a library, and you can copy it just from Win library, as easy as that. And we can put it in GC code as essentially a complete library. You can take a source and you can compile it yourself, or you can take already executable essentially. So that's how I see it, and it's coming very, very nicely. One more thing which I wanted to add here, I found, so I was playing with our rCanada package, and by the way, you would see that I'm using data. I'm using data already, so I've created use data. But COVID data, for whatever reason, I cannot read them anymore from UFT dataset. It's not our problem, it's on their side, essentially. Or maybe from my government network, it no longer allows me to actually to open. So these lines, I could not read them anymore. So I was running it. So I don't know why. Last time I was able to do it. So because of that, I will not be using COVID to show, to play with, but maybe we'll switch to PSAS data. PSAS data, we seem to be able to open it. So thank you very much. It's 1 o'clock. Everyone have a wonderful weekend. It's beautiful weather. Blackbird will sing for you. Blackbird singing in dead of night. Okay.
All right.
Bye, everyone.
Have a good one.
For those who are still here, I'll play. Blackbird singing dead of night. Take these broken wings and learn to fly. All your life, you're only waiting for this moment to rise. Blackbird singing dead of night. Take the sunken eyes and learn to see. All your life, you're only waiting for this moment to be free. Blackbird flies, blackbird flies into the light of the dark black night. Ok, bon fin de semaine tout le monde.
Bonne fin de semaine, Dimitri, merci.
Oui. Ok, à vous
Bye
tous
bye.
aussi, à vous tous. Ok, ciao.
Bye.